Now we're going to take applications on the solution of the triangle, the angles of elevation and depression. The angle of elevation, we have an object above the observer's eye. The observer's eye is looking upward, so the angle is above the horizontal ray. This is called angle of elevation. The angle of depression, the object is below the observer's eye, so the observer's eye is looking downward, so the angle is below the horizontal ray. This is called angle of depression. Remember how to solve a triangle using the sine law. If given two angles and one side, we can solve the triangle using sine law. We have triangle ABC. Use the capital letters for the angles and the small letters for the sides. Side A is opposite to angle A. Side B is opposite to angle B. Side C is opposite to angle C. The length of the side A over the sine of angle A equals length of side B over sine of the opposite angle B equals the length of the side C over the sine of the opposite angle C. So A over sine A equals B over sine B equals C over sine C. The cosine law, we can calculate the length of the side of a triangle in terms of the two other sides and the cosine of the opposite angle. So C squared equals A squared plus B squared minus A times B times the cosine of the opposite angle C. So C squared equal A squared plus B squared minus 2AB cosine C. We can use a simplified form of the cosine law to find the measure of an angle directly. To find measure of angle A, cosine A equals B squared plus C squared minus A squared over 2BC. So cosine A equals B squared plus C squared minus A squared over 2BC. Use the cosine law if given the lengths of three sides of a triangle, or if given the lengths of two sides and the measure of an included angle. Now example 1. From the top of a tower of height 60 meters, the measures of the two angles of depression of two boats were 34 degrees and 25 degrees. If the base of the tower and the two boats are collinear and the two boats are on one side of the tower, find the distance between the two boats to the nearest meter. We have two boats, say C and B, and start by drawing the horizontal lines that represent the sea level, then draw a vertical line that represents the tower of 60 meters height. At the top of the tower A, draw a horizontal line that represents the side of the two angles of depression. We have two angles of depression. We're looking from the top of the tower to the two boats. An angle of depression is below the horizontal ray, so go down, draw the two rays that represent the two other sides of the two angles of depression, 25 degree and 34 degree. To find the distance between the two boats, this is the required distance, this distance. Start by the first triangle ADC. Get the length of AC. This is a right triangle. We have the length of the tower, so we have one side. Here we have a Z letter. Measure of angle C equals 34 because they are alternate angles. In triangle ADC, we know the length of AD, so we have one side and the measure of one angle. The other angle is 90 degrees. Then we have two angles in one side. We can use the sine law to find the length of AC first. A side over the sine of the opposite angle equal the length of the other side over the sine of the opposite angle. First, in triangle ADC, this right triangle, we have AD over the sine of the opposite angle, which is 34. So AD over sine 34 equals AC over the sine of the opposite angle 90 degree, which is 90D, which is 90 degree. So over sine 90, of course sine 90 is 1. AD is 60, so 60 over sine 34 equals the length of AC over sine 90 is 1. Cross product and find AC. So AC equals 60 over sine 34. Use the calculator. This is equal to 107 meters. To find the length of BC, the distance between the two boats, we can solve the triangle ABC. We know the length of AC. We need to find the length of BC. Here we have another Z letter. Angle B equals 25 degree. So angle B equals 25 degree because we have alternate angle. This equals this. Get the measure of this angle by subtracting the two angles of depression. So 34 minus 25. 34 degree minus 25 degree equals 9 degree. This small angle measures 9 degree. Solve the triangle ABC. We know one side and two angles. We can use the sine law. The length of the known side over the sine of the opposite angle equals the length of BC over the sine of the opposite angle, 9 degree. So 107 over sine 25. So 107 over sine 25 equals BC equals BC. So BC over sine 9 degree over sine 9 degree. Now cross product to get BC to the nearest meter. So BC equals 40 meters.